Hello again. If you have downloaded the URSim 3.4.5.rar file, you can extract it and it will become a folder like this, and you will have these files inside it. In this video, we will see how to start this virtual machine in VMware. You just have to start VMware workstation or player and click open a virtual machine, and you have to give the path where you have extracted the RAR file for the virtual machine. You will have this file name inside it. Click open. Generally you won't need to change any settings, and then you just play the VM from this button, power on this virtual machine. It will take some time to load the virtual machine, roughly about a minute. My first program that I will open will be movel.urp. I will explain the program. Let me first explain the layout of this virtual machine desktop icons. There are 3 programs and 3 folders. The first program and folder are for UR3. The program is the software PolyScope. Similarly, the second program is for PolyScope for UR5, and consequently the folders to place the program for UR5. And third is the program for PolyScope program for UR10, and correspondingly the folder where you should place your program for UR10. I'll open the UR5 PolyScope, double clicking, and I have some programs in my UR5 programs folder. Safety configuration format has been automatically updated. The safety configuration remains the same, but the safety section may be different. Just press OK on this prompt. Okay, there are 4 buttons: run program, program robot, setup robot, and shutdown robot. I'll go to program robot, and there are 3 more buttons: load program, pick and place, empty program. Empty program we use when we want to start a new program. Pick and place is a template for a simple pick and place program, and load program is the button you need to press if you want to open an already saved program. I'll use this, and I'll go for Movel URP. Open. This is a very simple program for beginners. This is the Movel. This is the. Let me show you how it looks like when you open a blank program first. Let's go to robot program and empty program. When you open empty program, you see this. You see triangles stating robot program, and then an empty rectangle and empty. So now let's open the Movel program again. So it means that this Movel is the first instruction that has been inserted into the program. Let me introduce the tabs as well. The first tab is program tab. The second is installation tab. The program tab, from the program tab you can access 4 more tabs like command, graphics, structure and variable. We'll come back to this again. Let's go to installation tab. Many settings can be done here, namely the TCP, tool center point, center of gravity and payload, safety settings, variable, Modbus, Ethernet, Profibus, Profinet. This is for advanced user. The next tab is Move tab. This is a tab where you can come to move the robot easily. There are different joints: base, shoulder, elbow, wrist 1, wrist 2, wrist 3. By pressing these buttons up and down, you can move the robot in forward or reverse direction. Each robot joint in forward or reverse direction, or either in other word, you can say the clockwise or anti-clockwise direction. And I'm pressing the base button, so base is rotating counterclockwise, now clockwise. Similarly for shoulder. Now similarly for elbow. This is the elbow, this joint is the elbow, this joint is the shoulder. There are 3 wrists, wrist 1, and full zoom is already there. This is wrist 2, see it's rotating. And third is wrist 3. We can move it a little bit like this, see what's happening. Okay. Similarly, these are Cartesian controls, because the difference between these two are that these 12 buttons only control the rotation of a motor at each joint, or each of the 6 joints, but these buttons control the motion of the tool center point, which is usually at the center of the wrist 3. In other words, I can say that if I press this button, I can move only one motor at a time. But if I press this button, multiple motors will move, which are being moved based on the kinematic calculations of the robot controller. Again, multiple motors are moving, multiple motors are moving again. So this all is calculated by the robot controller. So how much current, how much degrees of rotation to be given to each motor joint. Enough about this. Another one is the IO tab. IO tab is for the physical input output signals. I can switch on or off a digital output like this. This is on. The output channel 0 is on, switched on, and output channel 0 is switched off. Then there is a log tab, which you can see the messages from the controller, and these values will be dummy values because this is just a simulation. These are the temperatures and currents of the joints. Now we come back to the program tab. Program tab has 4 additional tabs: the command tab, the graphics tab, the structure tab, and the variables tab. The first tab, it relates to a command or instruction. Whenever you click at any instruction, the settings on this page will change according to the selected instruction. For example, if I selected move L, These settings are for Movel. For this particular Movel, I can change the move L to move J or move P. Move L is move linear, move J is move joint, and move P is a complex move which can involve circular moves as well. I'll switch back to move L. Now, if I click to waypoint 1, the command tab will change. It will show the settings for the waypoint 1. Similarly for waypoint 2, 3, 4. So these tabs change their contents whenever you click at a different object in the robot program window. Let's go to the graphics tab. The graphics tab shows you a simulation of the robot which you can play and see what the robot will do when the program is running. Thirdly, there's the structure tab. This is the tab that you use to develop your program. It also have multiple sub tabs like basic, advanced, wizards. The basic tab shows you 1, 2, 3, 4, 5, 6, 7, 8 instructions. The move instruction, the waypoint, wait, set, pop-up, alt, comment, folder, and also some controls to move your function blocks or programming language elements like move up or down, copy, paste, cut, delete, or suppress. I'll just show you how to add a move instruction. Click the move and it will come with a one waypoint already there, and you click the waypoint and then click waypoint, waypoint, waypoint. So this is how this program was made. Now I'll just remove this, and further some settings would have been done for each waypoint. I will remove this one. Similarly, there are some advanced instructions: loop, subprogram, assignment, if else, script code, event, thread, and switch. This will be covered in the future programs. And lastly, there are some wizards: direct, seek, conveyor tracking, and force. The last tab is the variable tabs. When you run your code and you have some variables, though the real-time values of those variables will be displayed here for troubleshooting and debugging. I think we have covered all the tabs, most important tabs of the software, and we can quickly go to these waypoints and see what these waypoints are. Now I will scroll through these waypoints and you will see that this small robot here will change its orientation. Waypoint 1 looks like this, waypoint 2 looks like this, waypoint 3 looks like this, and waypoint 4 looks like this. Again I will go to waypoint 1 and see graphics. You see here, there is one robot which is solid and then one robot which looks like a shadow. Clicking on 2 moves the shadow robot. Clicking on 3 moves the shadow robot again. Clicking on 4 moves the shadow robot again. So you can visualize multiple poses of the waypoints through this way. But if you want to go to see the parameters of each waypoint, like waypoint 1, what you will have to do is you'll have to press move robot here first, and then keep pressing auto until the robot moves to this location. And when the robot has moved to this location, or the parameters set for this location, or set parameters set for this waypoint, then you click OK, and then you click change its waypoint. So now the values of x, y, and z, and rx, ry, and rz, the rotations about x, y, and z axis, and the degrees of all these 6 joints correspond with what you have set for waypoint 1. Click OK, or you can change the values by moving the joints or moving the TCP, or directly entering in these values, or moving by clicking and moving the robot from here. Similarly, if I want to go to waypoint 2 and I want to see the coordinates set for waypoint 2, I should first go to move robot here and click auto to move the robot here. Click OK and then click change this waypoint. This time the parameters shown are for waypoint are the ones that are set for waypoint 2. So let's play this program. Now we have enough understanding of what's happening. Let's play this program. Now, why does the art software go into auto move and ask us to press auto again? Reason is we moved the robot to waypoint 2, but as per the logical sequence of the robot program, it should start from waypoint 1. So when you press the play button, the software will ask you to move the robot to the waypoint 1 first before it can start. So let's keep pressing the auto button, and if you move to the first position, the first waypoint, press OK. Now it is ready to start because it is at the position of waypoint 1. I will press the play button and the robot is moving in a motion which is defined by the 4 waypoints. You can change the orientation of the robot. If you don't want the shadow, click this button. Sorry, click this button and shadow will be no more. You don't want the line, just the points. You can click this. You just want the line and not the points, click this. You don't want the robot, just click this. If you want the base, you can click this. This is a very simple program. And hope you have enjoyed this tutorial.